All right, welcome everyone. Today we're going to be looking at solving absolute values today. An absolute value, if you're not familiar with this term, basically tells you the distance from zero on your number line. So if you ever see these straight bars, like around a number, those are absolute values. So they're not parentheses, they're absolute values. So basically, we'll see how they work. But essentially, if you think of a number line, if you have the absolute value of 4, well, how far away from zero would that be? Well, it's 1, 2, 3, 4. So it's 4 away from zero. Similar idea with -4. Use a different color. How far away from zero is -4? Well, it's also 4 away if you count on the number line. So essentially, if you have an absolute value, if it's positive, it stays positive, or if it's negative, it turns positive. So when you take an absolute value, you should always get a positive answer because it's going to be a positive distance. You can't be a negative distance away from zero. How about you guys try the next two? What would the absolute value of 2 be? And what would the absolute value of -2 be? All right, assuming you gave those a try, the absolute value of 2, well, that would just be 2 away from 0, right? So that would be +2. The absolute value of -2 would also be 2 away from 0. So like I said, basically with absolute values, if it's positive, it stays positive. If it's negative, it turns positive. That's an easy way to kind of keep it straight. Really what we're going to be focused on next are absolute value equations. One thing that's unique about absolute value equations is you're really going to get two solutions. The reason for this is, for example, this first example, the absolute value of 2x minus 1 equals 5. Consider there's really two ways this could equal 5. Remember, the absolute value of 5 is equal to 5, and the absolute value of -5 equals 5. So essentially what we want to figure out is, how would we make that inside part equal +5 or -5? So when you're solving absolute value equations, we kind of write two separate problems. You take what's inside your absolute value, set it equal to +5, and you're going to take what's inside your absolute value and set it equal to -5. And then just like what we've been doing, you would solve this equation. So you would add 1, you get 2x equals 6, divide by 2, you would get x equals 3 for one of your answers. For the second one, if you add 1 over, just be careful with that -5, that would be -4 when you add 1 to it. And then divide by 2, you'll get x equals -2. So those would be our two solutions. And you could plug these in. For example, if I plugged 3 back into here, I would see I get 2 times 3 is 6, minus 1, that would be 5. So the absolute value of 5 is 5. Or I could plug in -2. -2 times 2 would be -4. Minus 1, that would be -5. So the absolute value of -5 would be 5. You would see both of these solutions are true. Let's look at another example, though. Sometimes you'll see problems with extra stuff. Really what you want to do is get the absolute value part by itself. So if you have things in front or around it, you kind of want to get the absolute value part by itself. So like an example like this, you first want to add that 1 over. So you'd have 3 times the absolute value of x plus 2 equals 9. You might be tempted to distribute this 3, but you can't distribute into an absolute value. It doesn't work like parentheses. So if you have a number in front, it's similar if you just had 3x equals a number. To get rid of that 3, you're going to divide it. So same situation with this absolute value. To get rid of that 3, we're going to just divide both sides. So we would just have the absolute value of x plus 2 equals 3. And now that we've got the absolute value part by itself, we're going to split it into two separate equations like we did in our first example. So I'm going to kind of write these over here because I'm running a little bit out of space. But you would have x plus 2 equals +3, and you would have x plus 2 equals -3. And then you would just solve these simple equations. So I mean, you would just subtract 2, you would get x equals 1. You would subtract 2 from -3, and you would get x equals -5. So, and like I said, if you plug these back in, you would see that both of these would equal 8. All right, so if you flip to the back side of your note sheet, one thing you need to be really careful when you're solving absolute value equations is sometimes something called an extraneous solution can happen. Basically, an extraneous solution is a false positive. It's an answer you get at the end that's not actually true when you plug it in. This only happens if you have variables on both sides. It's not always going to happen when that's the case. But if you have like an x on both sides of your equation, you do need to check your solutions. So that's why I wasn't as big of a worry on the front side, because both of these problems, we just had it equals a number. You won't get extraneous solutions in that case. But a problem like this, where I have an x on both sides of my problem, we got to be really careful when we check our answers. Because like I said, you can get extraneous solutions or basically an answer that's not true. So let's look at this example. So we've got our absolute value part by itself. So we're ready to kind of split up our equation into two parts. So like I said, you keep that inside part the same. You set it equal to the positive version of the right side. So that would be positive 6x. And then you're going to set it equal to the negative version of that the right side. And then we're just going to solve these equations. So there's different ways you could do this. I like to get the x's to the same side. So I would personally just subtract the 4x over. So that would give me 10 equals 2x. And then I would just divide by 2. So if I do that, I'll get 5 equals x. That's one of my potential answers. Similar idea on the second equation. Like I said, I like to get the x's on the same side. So I would start by subtracting 4x myself. So you would get 10 equals negative 10x. You combine those like terms, divide that negative 10. You'll get negative 1 is x. So like I said, though, if you have an x on both sides of your equation, you really want to check that this is going to give you a true solution. So you're going to plug this back in to your original equation. You want to see, are you going to get the same thing on both sides of your equal sign? So for example, if I plug in 5, I'll kind of write my work over here. I'll erase it in a second. But if I plug it in that absolute value, I'd have 4 times 5 plus 10 equals then 6 times 5. So I'm running a little bit out of space, but if I work out that inside, that would 4 times 5 is 20 plus 10. That would be the absolute value of 30. 6 times 5 is 30. That would be true because the absolute value of 30 is 30. So this is a solution, but let's check our negative 1 solution. Let's see if that one's a true solution. I'll do this in green. So if I plug that into my absolute value, that would be 4 times negative 1 plus 10. And then I want to see, is that going to be equal to 6 times negative 1? So 6 times negative 1 is going to be negative 6. So we want to see what we're going to get inside this absolute value. Negative 4 times negative 1 is negative 4 plus 10. If you put that in your calculator, you're going to get positive 6. Is the absolute value of 6 equal to negative 6? No, that's not true. The absolute value of 6 would be 6. So this is not a solution. It's called an extraneous solution. So if that happens, it's just not an answer. So like I said, you got to be really careful if you see x's on both sides. You really do need to check your answers. They'll try and trick you. Like if you did see a question like this on the ACT, they might give you a question that has a false positive or a solution that's not really a solution. And then the only other thing I just wanted to kind of say is absolute values can never equal a negative number. So if you ever get your absolute value part by itself and it equals a negative number, there's just going to be no solutions. If you see something like this. This is only true if your absolute value part is by itself. Like for example, if you had something like this isn't no solutions because once you add this 3 over, you're going to get your absolute value equals a positive number. So just be careful if you're ever solving, or if you have an absolute, like for example, if you have the absolute value of x minus 2 equals negative 12, since your absolute value part's by itself equals a negative number, just stop. You can't, like even if you solve it, you're going to get answers. If you plug them in, they're not going to work. So just be careful about that. You connect. If you think about it, like what we first started with on our number line, remember an absolute value can never equal a negative answer. So if you ever get that situation when you're solving an equation, stop yourself, don't waste your time. There's no solutions. But I hope this goes well. Let me know if you have any questions once you get into your Delta math for today. But I hope things are going okay so far.